Hello, everyone, and welcome to Lesson 2 of the Quadratics unit. Today we're going to talk about properties of quadratics. We're going to see different features, okay, so we can get ready to start graphing quadratics. We're going to learn about three main forms of quadratics, okay, and recognize what each form tells us, where it's most efficient, so we don't always get stuck with, well, we have to put it in one form. We'll have three different forms for it. So let's start with factoring practice. Go ahead, pause the video, try these out, use the different factoring methods we've had. When you're ready, unpause the video. I'll show you some answers, kind of give you a brief insight of what I did to solve or to evaluate and factor. Okay, so hopefully you felt pretty comfortable with doing these. The top two I see have as a GCF. The middle one to me looks like it's a difference of squares problem. Okay, so the top one I factored out a 3, and then we can use the box method, or we can see what multiplies to negative 12 and adds to 4. Middle one factored out to 4, got different squares problem. 1 times negative 1 is negative 1, and the square root of x squared is x. Third one, same idea as the top. You can make the box. You don't need to. Just testing 2 negatives multiply to a positive, and 2 negatives add to a negative. So the more we practice these, the more we practice our multiplication facts, the more fluent we get in factoring quadratics. So today we're going to keep dealing with polynomials and quadratics. So degree 2 polynomials. So every function today we're going to see has x squared in it. And today we're going to talk about the vertex, which is the topmost point or the bottommost point, the concavity. So does it open up and does it look like a U? Or is it upside down and look more like the letter N? Not really like the letter N, upside down U. And what are the x-intercepts, which we'll also call the roots, and we'll also call them the zeros. If I ask you what the roots or the x-intercepts of a function are, those are really important points, okay, to where the height is 0. So today, we're going to introduce three forms of a quadratic. Standard form, vertex, also called graphing form, and factored form. Now, I recommend setting aside half a page or even a full page of notes for each form, because each form has a lot of good information it tells us. And depending what information I want to know is which form I would like to have. So let's start looking at some of the forms. Standard form is a form that we are very commonly seeing, where it's ax squared plus bx plus c. In the warm-up, two of those were in standard form. Actually, all three of them were in standard form. So the y-intercept, this one, standard form, gives us the y-intercept. This c value, the constant, is our y-intercept, because we learned previously that the y-intercept, we put in 0 for x. So if you put 0 for x in both spots, anything times 0 is 0, plus anything times 0 is 0, and you're just left with c. So when in doubt for the y-intercept, put 0 in for x and see what you're left with. In this case, it's just c. Now the vertex, and some of you may be familiar with the quadratic formula, negative b over 2a, okay, this has helped us use the quadratic formula, but this finds the x-coordinate of the vertex. So you take the opposite of b and divide it by 2 times a. And whatever x value you get, you put into the equation to get the y value, or the f of x value. So f of negative b over 2a means take whatever x value you find, put it into the equation, and evaluate for y, or f of x. Now the a value in front of the x squared is going to tell us how stretched it is, the vertical stretch. And if a is positive, the graph is concave up. So U-shaped, and if A is negative, the graph is upside down. Now, there's one more piece of information that standard form gives us. It's the discriminant, which is b squared minus 4ac. This is going to be a number. We put our values in for b, a, and c, and we get out a value. This should also look familiar if you remember the quadratic formula. So now three things could happen. The discriminant could be positive, it could be equal to 0, or it could be negative. And that will tell us how many times the graph touches the x-axis. And all of this information is really useful. So let's take a look and let's do an example together. So I have a standard form quadratic, x squared plus 4x minus 12. I think this might have been the one from the warm-up. Complete coincidence. So first, I want to look for the y-intercept. Now, if I don't remember the rule, I can put in 0 for x and get out a y, which is what I did. I put 0 plus 0 minus 12. So the y-intercept is negative 12. 0 comma negative 12. Now the vertex, that was the negative b divided by 2a. So to find the x-coordinate of my vertex, I do negative b, so the opposite of 4, which is negative 4, divided by 2 times 1. Now the a value is a number. Please don't tell me that a is x squared. See it every year, and we're allowed to make that mistake once, but a, b, and c are numbers. So in this case, a is 1, so negative 4 over 2 times 1 is negative 2. So I found the x-coordinate of my vertex. Now I'm going to put the x-coordinate back in and put negative 2 in everywhere I have an x. So negative 2 squared is 4. 4 times negative 2 is negative 8. Minus 12 is negative 16. So my vertex is negative 2, negative 16, which is going to be really important when I need to graph this function. Now my a value is going to come in handy again. My a value is 1, which means the graph should open up, should be U-shaped. And the question also might ask find the discriminant, which is 4 squared, b squared minus 4 times a, which is 1, times c, which is negative 12. So my discriminant is 64. That tells us I have two x-intercepts. It doesn't tell me what my x-intercepts are, but I graphed this and I could see, okay, it's got two x-intercepts. I can see my vertex down here is negative 2, negative 16. In a future lesson, we're going to be responsible for graphing an accurate parabola. But right now, we're just figuring out what details does each form give us. So standard form, yeah, I will write this down. Standard form, very easy to find the y-intercept, very easy to find the vertical stretch, great for finding the discriminant, okay for finding the vertex. Vertex in this form is a little more challenging, but we could still do it. That's what standard form tells us. Now it's your turn. Okay, I want you to find the y-intercept, the vertex, the vertical stretch. Does it open up or down? And the discriminant. Pause the video. It should take you a few minutes to try this one. So try it out. If you make mistakes, I want you to make them now. When you're ready, unpause the video, check our answers. Okay, so our answers. Now, I would circle or put a question mark next to the ones you got incorrect. Think about, was there a calculation mistake? Did I not know which formula to use? Or was there another mistake? Yeah, I'm happy to discuss them. Or you should rewind the video and rewatch how we can go through each step. Now the next form is vertex/graphing form. This form is my personal favorite to graph, and hence the name graphing form. Okay, really nice because this gives us our vertex. Okay, our vertex is h comma k. If you remember the linear functions unit, we had point slope form, which gave us our point and our slope. This does the same thing. This gives us our vertex, which is a point, and then the vertical stretch. So just like standard form, if A is positive, the graph is U-shaped, it opens up. If A is negative, the graph's upside down and opens down. Like I just said, the form very efficient because it provides us the vertex and the vertical stretch, which in the next lesson we're going to see graph the vertex, how to graph other points and make a nice pretty graph. And this form also is not terrible for finding the y-intercept. You put 0 in for x, and we evaluate to find the y value. So once again, we'll take a look at an example. Okay, we got graphing form. You're going to be very used to seeing this form and immediately know, hey, I got my vertex. So my vertex is the opposite of 2 and negative 16. So negative 2, negative 16. Inside, opposite sign. Outside, same sign. Now my vertical stretch is this value right here. It's 3. It's positive, which means it opens up. And for the y-intercept, I'm going to have to do some work. Okay, I know that x is 0, so I put in 0 for x. I can do 0 plus 2. I can square it. I can multiply that by 3 and subtract 16. Or you can put it all in a graphing calculator and evaluate it. And you get negative 4. So 0 for x, negative 4 for y. That's my y-intercept. Now, vertex form is great for finding the vertex. It's great for finding the stretch and telling us, does it open up or down? Also very good for finding the y-intercept, just takes a few steps, a few evaluation steps, which you can do. And now you're going to do them. You're going to practice. So once again, pause the video. Tell me all the good information here. When you're ready, unpause the video and you'll see, did I get them right or do I need more practice? Okay, so let's look at some of the answers. Vertex, vertical stretch, both directly in the from the equation, opens down because of a negative sign, and my y-intercept I put in 0 and I evaluated for 0 for x and I evaluated for y. Okay, probably my favorite form is vertex form, especially if someone's telling me graph this. It gives us the information, gives us a lot of good information. Now the last form we're going to talk about is factored form. Factored form is great for solving. So keep that in mind in the future lessons. When I say we're going to solve, factoring is going to be one of the techniques we use. Factoring also is ideal for the x-intercepts. Okay, it's the form where we have an a value times x minus a number times x minus a number. There could be positive signs in here, and that works as well. Okay, now the b value and the c value are my x-intercepts. Certain quadratics have two x-intercepts. If it's factored like this, I know it's going to have two x-intercepts. Now that's the easy part of the factored form. The more challenging part is the vertex. So the vertex is in the middle of the two x-intercepts. That goes the same for every single parabola. Any parabola you graph, the vertex has to be right in the middle of where the x-intercepts are. And we're going to see that in action. That's a lot of terms. So if you want to pause and write that down, that's great. I will show you what this looks like in context. And then the last two rules are the same for the other forms. The A value is always the vertical stretch. Positive opens up, negative opens down, y-intercept for every single function ever, quadratics, linear, any other functions we do the rest of the year, put 0 in for x, find f of 0 to find your y value. So here we go. Here's an example problem that we're going to do together. So for x-intercepts, I need to figure out what x value would make each parenthesis 0. So if I put a -6 in this first parenthesis, -6 plus 6 is 0, so -6, 0 is one of my x-intercepts, and 2, 0 is one of my x-intercepts. Now here's where I said it's going to get a little challenging, but we're going to do this. The vertex. I need to first find what's in the middle of -6 and 2. So what I can do is I can add them up and divide by 2. So I'll get -4 divided by 2, which is -2. Now, once I know an x value, it's not too bad to ever find the y value. Put -2 in for both x's. So if you want to, you pause the video, you go ahead and do that. Get comfortable with the calculator. Get comfortable with your mental math. You can do it. And you get -80. So 5 times -2 plus 6 times -2 minus 2. 5 times 4 times -4. Once you know one coordinate, put it in, you can always find the other coordinate. I knew the x, I can find the y. Now we've done vertical stretch, we've done concavity multiple times. Positive opens up. 5, which means it's stretched. And when we get to graphing it, we're going to see what this stretch looks like on a graph. And then for the y-intercept, you put 0 in for x, you evaluate. So 6 times -2 times 5 is -60. That's my y-intercept. Now to finish it off, you're going to try an example. You're going to pause the video, try it out. Tell yourself, what steps can I do? What steps do I need extra practice on? What steps do I have questions about? When you're ready, you unpause the video and we look at the answers. Okay, so here are some answers. Okay, 1 makes the first parenthesis 0, 7 makes the second parenthesis 0. In the middle of 1 and 7 is 4. I put 4 in for x and get a y value out. Okay, that vertex step should take you some time. My stretch. Some of you may have said, well, it's got no stretch because there's not a value out here. But there is. It's just 1. Okay, that's the normal stretch. If we know what x squared looks like, this is going to have the same stretchiness as x squared, which we'll talk about in the next lesson. This graph opens up because a is positive. I could put 0 in for x and solve for y and get a y-intercept of 0, 7. So this form, best at finding the x-intercepts, and we can still find the vertex. And that's the 3 forms. We're going to be practicing standard form and vertex form and factored form, and we're going to be great at all of them. So make sure you continue to practice and you ask any questions you have about any of these 3 forms. And next lesson, we're going to take this information and put it on a graph.